in data management, data preparation, and today I will share you the best practices for data management for modeling purposes. For decades, machine learning was too slow to evolve given the complexity of the algorithms and not sufficiently large data sets. But today, enterprises are diving into machine learning with a more positive outlook thanks to major advancement in new technologies, software development, given the higher processing power, graphical processing power, and of course availability of rich massive data sets. But what is machine learning? Simplified, I would like to explain like we have a data. Businesses today generate a lot of data, and what we would like to achieve is get some answers, achieve some goals, find some answers from that data. And machine learning is all about that. So we take that data, we apply some algorithms, statistics, mathematics, some science, and with the greatest mind of machine learning engineers, we strive to achieve some insights, to get some insight from the data, to solve problems, to find answers for some of our questions and make decisions that will improve our business. Designing, deploying, and managing effective data architectures is critical for the success of the machine learning project. Implementations require flexibly and efficiently supporting high-scale data flows to minimize the risk of project killing bottlenecks. With stable and efficient data architecture in place, you can realize the promise of machine learning and continuously improve the results you deliver to the business. First, you have to realize what is your use case. Machine learning has a lot of applications. For example, it's product recommendation, in fraud detection, in some disease identification. After you are understanding the business and the use case and the problem that you want to solve, you have to define the data set. Data set is one of the most crucial parts in machine learning projects. For example, and it comes in with different nature. Data could be from some storage, centralized storage. It could be from live stream, real data coming from clicks on the internet web pages, and so on. After we know the nature of the data set, we have to define how the data should be prepared for the machine learning projects. Because data comes from different sources, we have to find the right sources that we would like to use in our machine learning project. We have to define the requirements and transformations of the data that could help to improve our project. Here we come to a lot of data preparation challenges. For example, lack of necessary data. Businesses are generating a lot of data, but for our particular problem that we have to solve, we could have the problem that some data is missing, or there is no clear picture about the data available. We receive data from different sources, from data warehouses, databases, or some other sources, and sometimes it's very complex and not straightforward to understand what data we have available for our project and what data is missing. And usually the data that we get, it's not ready to use. From those systems, we got raw data that it's not prepared to directly input into our models. So we have to make some transformations here. From also those systems, data comes into different formats. So we have to converge those formats and prepare data so that we have only one format using in our models. And data that we get from real world, it's a really messy data, unbalanced data. So we can have problems with unbalanced data, and models could not perform well. So the data preparation is a crucial part for modeling. Because we have different cases, for each case we have differently to prepare data. So data preparation for stream coming from real data coming from stream, it's a different from data coming from data warehouse, for example, or some centralized data storage. So you have to architect a data pipeline for each case. Then when we know how the data comes, where it comes from, what are the right sources from data, how we should prepare the data, then we should wisely select our data platforms. For example, if we have some smaller data set that doesn't need a lot of preparation, we could use normal tools for data preparation. But when it comes to complex data sets that come from varied sources and are large. For example, if we are talking about big data, maybe we should use some technologies who allow us to process this data fastly and better. For example, we could use the distributed file system, or maybe some databases like Amazon S3 that can efficiently process the large and complex data. For example, if it's a stream data, we could use Kafka, which is managing system that can support real data and streaming. And after that, you could create a persistent sort of records for historical analysis. Then, of course, very important thing is to plan for fast growth. When the data is prepared and we have chosen the model and we have finally the model and we deploy the model in production, of course, here project is not ended. We should plan also on the production, what kind of data we will have, and of course, to allocate significant buffer of capacity and processing unit and storage and, for example, network for each data pipeline in order to have a good performance. And when the model, once you deploy it on production, then after some time when we got a new data or we see degradation of the model, maybe we would like to retrain the model. And of course, here we have to understand that maybe there will be some adjustments underlying how we prepare data, how the new model is deployed. Is the new model better than the already existing model? And here we could have a different data sets for different models, and we have to be prepared for that. Also, we have to plan for fast and frequent iteration, because in production, it could happen that the data flow is very frequently, and we have to prepare it, including the all feature engineering and selecting and replacing algorithms and so on. So we have challenges on different fronts. But to avoid all the problems and to be prepared for that, we have to monitor and refine data flows. We have to configure and analyze each task regarding the data, what is happening on the production, and so on to improve better performing of the model. So here, after everything I've said, I would like to ask, what do you think? What is the biggest challenge of machine learning project? I have given here some answers. I would like to think about that, and to have 2 minutes. I have prepared some interactive answering tool here. You could scan the QR code, and then we will see the results and we will analyze. Please do not change your answers. And of course, I will not use this data to train my models. It will be stayed secretly, and I will not share with anyone. Okay, I guess this is the answers. Yeah, you have data consistency. It's a big challenge in machine learning project. As I said, real data is really messy and it's really inconsistent. So data preparation for good data preparation for a machine learning project and input into the model could take a lot of effort and time. Also, other challenges that appear in machine learning projects are wrong model choice, for example. But if we understand good the problem that we are solving, there are different techniques. And if, of course, if the modeling person is not it has knowledge how to build and perform a good model, we could find the solution. Also, overfitting is a problem that it comes when executing machine learning project. It comes usually when we have a small data set or we have a noisy data sets that there is some noise that is making problems about the model, and on the tests, on the trained data set, model is performing good, but when we apply in a new unseen samples, it perform bad. But also there are techniques how to detect and solve overfitting problems in our projects. Thank you for your answers. So here I will present now a machine learning workflow, how it's one machine learning project executed. Of course, a lot of we say that machine learning project starts with gathering data and defining all the sources. But before we gather data, I will say that it's very crucial to understand really the case and business problems and the case that we are solving. And after that, after we have a good understanding of the case, we could define the right data sources and how the data should be prepared and transformed. After the next steps, how the data should be transformed, how the, for example, errors or some missing data can be replaced, or outliers should be excluded, or some other anomalies in the data. When we have good prepared data, then we split the data into training and testing data set. And we perform the model. We build the model. For example, to build a good model and to have a good choice of a model, of course, understanding of the business is right. Then you have idea what models are suitable for solving that problems. And after that, after we build the model, we have to evaluate the model. So here we evaluate the models on a testing data set. Also, we have to clearly define what are the metrics, how we want to evaluate a model. For example, accuracy, if we take accuracy of the model, is that good metrics, or also performance and execution speed, computational costs, and also important metrics could be using business success criteria. After we evaluated the model and we decided that this model is good, we deployed the model on production. And before deployment on production, there are a few steps to be made. For example, we have to test this model, how it is integrated into other systems. Also, user acceptance testing if this model is good for business use. And also after the deployment, we have to maintenance and monitor the model. Machine learning projects steps, as I said, it could the steps could be executed manually. For example, those that is very common between companies that are beginning to apply machine learning. In this manual process is driven by data scientists, and every step is manually executed. Some script is executed, and it requires the time and the effort of the data scientist team. This manual process is suitable if we don't have a lot of iteration. For example, if the data comes weekly or monthly or once in a year, so this process could be of use. But if it's really frequent data, later we will talk about what is the best solution. Here we have a little bit splitted experimental environment and production environment. Training the model is done by data scientist team, and they prepare the model. But after that, the model goes to production. Maybe software engineers took the responsibility to implement the model into already existing environment and systems. And here it's we can see this connection between machine learning and operations, because the engineers who deployed the model need to make the required features used in model training available also in production for low latency serving. And this could lead to train serving skew, which is a difference between performance during the training and performance during the serving. This discrepancy between these models comes because we handle the data in a different way between when we are training and when we are serving the model in production. Also, the nature of the data when we are training the model could be a different, but from the data that comes into production. So the solution here is also to what is how the system is performing and what data changes are happening. Because goal of machine learning is to make faster and better productions, I'll introduce a new level of automation. Machine learning pipeline, for example, is used to automate the machine learning workflows. It's enabling a sequence of data to be transformed and correlated together into model which is tested and then evaluated, and improving the model results all the time. So data quality and data accessibility are two main challenges that come across when building a machine learning pipeline. But of course, data captured or data gathered and data processing and the benefits of collection should outweigh the cost of collection, because of course we need a lot of data into our model, but that could be a costly process. So here we have to think about that. Here, some of the characteristics of this automation is, for example, rapid experiment. We don't need to execute every step manually and running the scripts in behind. Instead of that, we execute the whole pipeline, and every step is orchestrated, and transition between steps is automated. And this pipeline that is built while developing the model also could be used in pre-production and production environment, which is some plus. But before executing the whole machine learning pipeline, of course, we have to implement data validation and model valuations. Because data coming into a pipeline should be examined, and if there is some discrepancies, the execution of pipeline should be stopped. For example, we could notice some data scheme skews, that is anomalies in the input data, and received data does not comply with what we expected for the model. For example, we could have some unexpected features or not receiving all the features, or receiving features with unexpected values. Regarding the data value skews, these are significant changes in the statistical properties of the data, which means that the data patterns are changing, and there is a need to trigger a retraining of the model to capture these changes. Regarding the model evaluation, as I said before, it's very good to define evaluation metrics, and comparing these evaluation metrics and comparing with some reference model, if that is a production model that is deployed on production, or if it's some baseline model, or with some other business requirements models. And you have to make sure that the new model produces a better performance than the current model before promoting to production. And here, before promoting to production, we should make all the testing, A/B testing, and so on. An optional additional component that comes to this level of automation is a feature store. Feature store is a centralized repository when you standardize the definition, the storage, and the access of the features for training and serving. And the feature store needs to approve, for example, an API for both high-through batch serving or low-latency real-time serving. And the feature values could support both training and serving workloads on production. Feature stores have become the key piece of data infrastructure for machine learning platforms, and they are helping data scientists in many ways. For example, we could discover and reuse already available feature and save some time and effort for building and feature engineering. Also, we could avoid having similar features that have different definitions, and maintain features and their related metadata. Also, here with using the feature store, you could avoid the problem that explained that is appearing actually training and serving skew, because using the feature in the training model and using the feature in the production will come from one centralized store, and we could solve this issue. And feature in this feature store could be used for experimentation, as I said, for continuous training the model, and also for online prediction. Here, additionally, we could talk about metadata management. Actually, information about each execution of the machine learning pipeline should be recorded and stored in order to see how was the performance of the machine learning pipelines, what were the error, debug errors, or see anomalies history in order to prevent those happening again in the future. How or when is the machine pipeline executed? So it depends again on the use case that you are having. For example, machine learning pipeline could be executed to demand if it's some experiment we are doing now and then it could be executed on schedule. For example, if you know that we are receiving, we'll have new data every day or every week, we could schedule the execution of the machine learning pipeline. But retraining frequency also depends on how frequently the data patterns change and how expensive it is to train the model. For example, on machine learning pipeline can be executed on availability of new training data. But if it's that really a cost, then maybe we should not execute or so on. Of course, also trigger for machine learning pipeline could be degradation of the model. When model is deployed into production, you could experience some problems with data, and if it's not monitored well, then the model could start decreasing the performance. And then maybe execution and building and preparing a new pipeline with the better data, it's a solution. Of course, this is all in theory. For example, automation is a great part and we will solve a lot of problems. But in real world, actually, sometimes we have to do our work by ourselves. Here I have stated some machine learning platforms. Some of them come with some costs, but in order to execute the machine learning project efficiently in saving some time, you could use these tools for building machine learning projects and handling the data. Also, there is another option for some open source free tools that are available. Python as a programming language also provides a lot of packages and libraries that allow us to build a proper machine learning project. Here, I would like to know, what did you find most useful in this presentation? Here I have prepared some QR code you can scan, and you could write in a few answers what did you find more useful in this presentation. Nice. I'm glad that you find. Yeah, it's true. Real machine learning is hard, and the real data is messy. It's not like everyone say it's easy. We will solve all the problems now. Yeah, I'm happy that you find these things useful, and in the real world, building machine learning projects, it's crucial. Data is crucial. So, to conclude, for example, for successfully executed machine learning project, is crucial to understand what is the business goal, what we want to achieve. After that, when we have the understanding, we should define the process, the whole journey, how we will come to that, how we will achieve that goal. And of course, never forget, well prepare your data. So if you have any questions, you can ask me now, or if you have another, you can write me an email. I have stated here my contacts. This will be everything for me.
Vprašanje napišite, dajte preko Q&A okenca, če so kakršnekoli vprašanja tam stavite. Okay, zgleda, it seems there are no open questions. There's one. So the question from anonymous attendee is, what is the typical frequency of model training? Anitsa? Do you hear me, Anitsa? Hello?
The cases of the use case, for example, if Hello?
Yes.
Can you hear me?
Yes, we lost you for.
Can hear you.
Yeah.
Can you hear me?
Yes, we can. The question was, what is the typical frequency of model training?
It's okay now.
Yeah.
It depends of the use case. For example, if we are building a model, recommend, for example, some that is used for marketing or some recommendation or products, it's a live stream data, it's a clickable data. So every time some user clicks on the internet, on the web page, and it's reviewing some products, we get a lot of data from live stream, and we have to retrain the model accurately with the frequency of upcoming data. For example, if we are build, for example, some solution for predicting disease detection, for example, we gather some data, or the people are tested, for example, once in a month or once in a year. So we perform, or we retrain the model, for example, when we get the new data in 1 month, in 1 year. So it depends of the use case. It could be a million times in a minute, or it could be once in a year.
Okay, a question. So in terms of models, and how the models are trained, so what's the most difficult part in training a model or finding the right model? What's the thing that comes in the most difficult way?
So when training a model, first we have to choose rightly the model, and before choosing and training the model, we have to analyze our data. So exploratory data analysis is also important to understand the nature of the data, statistics of the data, how it performs. For example, if it's how it performs in the past, what is historical trend, for example, and after that, on really prepared and really good analyzed data, we are training our model, and we choose the model based on the best performance on the given data, because on the different model it's suitable.
Okay, thanks.
Okay, any more questions for Anitsa? Okay, Anitsa, if there are no questions, let me thank you. For those who have questions for Anitsa, can contact her directly on her email. And yeah, thanks again, and see you on the next occasion.